Good afternoon, everyone. Can everyone hear me okay? Quick test, great. Welcome to my breakout session. Now, I'm sure all of you work in the tech industry in some form or another, but how often do you get to think about what the future of technology is going to be like in 5 years, 10 years? What kind of devices are we going to be interacting with on a daily basis, and how are they going to be powered? Well, I'm excited to talk to you today about how you can build connected apps using the Universal Windows Platform and .NET and the powerful tools in Visual Studio that will help you author these applications. I'm sure many of you are already somewhat familiar with the promise of Windows 10 and the Universal Windows Platform. And hopefully after seeing this session, you'll see that power in action. Now, Windows 10 and the Universal Windows Platform gives developers an opportunity to build a single application package that targets any one of these Windows 10 device families. Whoops. There you go, I'm really excited. But not only that, Windows 10 is a platform, and more devices over time will adopt this platform and adopt this application model. So the apps you build today may power the devices tomorrow without any code changes. It really is incredible when you see it in practice. Now, you'll be delighted to hear that for the majority of this session, we're just going to be in Visual Studio building an application, building a demo. But before that, about 20 to 30 minutes of your time, I want to give you a brief history of .NET, where we are today, and why that is important as a Universal Windows Platform developer. And then we'll build stuff. So, as I'm sure many of you are already familiar, we've had an interesting history with .NET. And I wouldn't say it's bad. I think it's actually really great, and I think we've learned a lot as we've developed these .NET platforms. So, what this diagram is showing is that each different .NET platform in the past was built on a slightly different app model with a slightly different framework and a slightly different runtime, all called .NET technology. Now, that was great. If you learned C# development, you were a C# developer. But the APIs you knew in traditional Windows desktop development, say Windows Presentation Foundation, may not have transferred perfectly to Windows Store development. So say the skills you learn in WPF development are phenomenal and you're an incredible WPF developer, that won't necessarily mean you're the greatest Windows Store developer. You'll have a great start, but the skills aren't going to transfer one-to-one. Now, we did instrument tooling to share code across different .NET platforms called portable class libraries. And portable class libraries were great for what they are, and they still are great technology today. What they enable you to do is to consider platforms that you're targeting and think about the API intersection of those platforms and share code across all of them. Now, while this is really great that you could write code that would transfer across all of the different platforms you're targeting, one of the challenges with portable class libraries is recognizing what that intersection actually is. I mean, honestly, can you read that? So that's really the shared code opportunity that you have with portable class libraries. And it was really great. But things are changing a little bit, and now I want to talk about .NET today. So with .NET today, we're investing a lot of our resources into these three core frameworks that I'm sure many of you are already familiar with. We have the traditional .NET framework, which powers many of the Windows desktop applications that you probably build, use, and love today. In addition, we have .NET Core, which is the driving technology under the Universal Windows Platform. And then we also have Xamarin. So I'm sure many of you are also interested in Xamarin, and I'll point you to some Xamarin sessions at the end of this talk, but we're not going to focus on that one quite as much. Ooh, something crashed on my other computer. So the one thing that I want to point out about these different .NET technologies is how .NET is delivered to the device. So many of you from traditional Windows desktop development may be familiar that you're limited to the .NET framework that is running on your customers' devices. So say you want to build an application that's targeting .NET Framework 4.6, because you want to utilize latest and greatest .NET technology. There might be some new APIs available or some fixes. Well, if your customers don't have .NET 4.6 installed on their devices, you can't really build it because they can't use it. With .NET Core and with Xamarin, these more modern .NET technologies, .NET is actually delivered with the app need be. Now, full disclaimer, we're not going to deliver .NET with every single app that ships on the device. If the same set of .NET libraries are used by multiple different applications, that version of the framework will be shared with a single .NET package so that we don't bloat the device with 30 different versions of the same .NET framework. However, say you do want to take advantage of new .NET technology, a new library, a new .NET Core meta package, as we call it, which powers the UWP platform. Well, you can actually just go ahead and do that. And I'll explain to you how you can change .NET in your app in just a moment. But what this really gives you is the ability to innovate at your own pace. You're no longer tied to what your customers have on their device. If you want to take advantage of new .NET APIs, go for it. It'll just be delivered as a part of your package. So these different .NET technologies power different app models today. So The two .NET Core platforms that exist today are ASP.NET Core and UWP, which I'm sure you're familiar with. And each one of these technologies has a different set of base .NET libraries. So the .NET Framework has the base class library, Core has Core library, and Xamarin has the Mono class library. And again, we're in a situation where we have similar technologies, similar APIs, but not a standard, if you will. So hopefully some of you have already heard about this, but what we've recently released, actually, is what's called the .NET Standard Library. Now, this is pretty new, so the tooling isn't quite caught up in Visual Studio, and I'll demonstrate what I mean when we get to the demos. But I think this is really, really powerful for .NET developers. What it is essentially a standard definition of what APIs need to be available in any .NET platform. And with the open sourcing of .NET Core, this is especially important. As additional app models come into play, built on top of .NET Core, there has to be some standard so that a .NET developer building an app for one .NET platform has the same skill set and can build for another platform. So let's take another example. Similar to the one before, what this chart is showing are the .NET standard versions that exist today. Each one of these represents the number of APIs available, not quite to scale, but each higher version contains all of the APIs in a lower version. So .NET Standard 1.6 is a specification of APIs that must include all of the APIs that predecess it. So let's take the example we looked at before. I have 3 platforms that I'm building my application on. I'm targeting, let's just say I'm building a cross-platform mobile application targeting Xamarin, UWP, with an ASP.NET backend targeting .NET Framework 4.6. Now, these are the 3 versions of .NET Standard that those platforms implement. So Xamarin implements version 1.6 of .NET Standard, meaning you are guaranteed as a developer that all of the APIs specified in .NET Standard 1.6 will be available for you in Xamarin. Same for UWP and .NET 4.6. So you could build a .NET Standard library targeting .NET Standard 1.3 and guarantee that all of the code in that library works across those 3 platforms. But that's not all. The way we've defined .NET Standard is to support pre-existing .NET platforms, but it's also forward-looking, like I mentioned. As more and more .NET platforms come into play, this is going to be increasingly important. So let's take that same example and say I want to run my ASP.NET application on a Linux server. So I need to target .NET Core in order for that to work. It's open source and it's cross-platform. So if I were to do that, I could migrate my ASP.NET application to .NET Core, and the same library I was already using, .NET Standard 1.3, would continue to work, no changes. I don't have to worry about the intersection anymore. I just have to worry about lowest common denominator of APIs. Now, in fact, I actually have additional APIs available to me because now my lowest version is the Universal Windows Platform targeting 1.4. Now, the reason UWP targets a version before .NET Core is because UWP was actually released before .NET Core. So not all of the APIs were built. It's built on essentially a pre-release version of .NET Core. Now that's going to change going forward, and obviously as the Universal Windows Platform evolves, and as Windows 10 evolves, more and more of these .NET APIs will show up, and you'll be able to write higher .NET Standard libraries to target the most modern platforms. Now I want to take a second there to ask if there's any questions, because it's a decent amount of information, but I think it's especially important. So just a brief pause, and if not, we'll keep moving. Great. So there's more information on this at aka.ms/.NET Standard spelled out. I point you to it at the resources at the end. But this is really cool. This means the skill set you learn building UWP apps are going to transfer to all future .NET platforms. So, I mean, you're really learning a valuable skill set here. So that's .NET as a whole and why it's important to UWP developers. But here are some interesting .NET specifics to UWP. So the first one is, how is .NET delivered? I mentioned it was delivered as a part of my package. Well, the way we actually do that is just through NuGet. So you have tooling in Visual Studio. You have the NuGet package manager. And if you want to go ahead and update the version of .NET that your application depends on, all you have to do is update the NuGet package. Not only that, but you can search for specific .NET Core libraries and update very individual libraries if you need to. So say everything is working except for this one library. Maybe there's a bug, and you can find that there's a bug fix on GitHub because that's where .NET Core is. Well, all right, I know that fix is there. Maybe it's in a pre-release version of that .NET library. I can just go ahead and reference that in my application, and it will deliver to the device. I'm no longer waiting for my customers for years to update their version of the .NET framework. Now, the last thing regarding the history of .NET and how it relates to UWP is .NET Native. So this is a technology that we released broadly with the Universal Windows Platform and only for the Universal Windows Platform for now. But what it does is it compiles your managed binaries, the code output you get from compiling C# or VB, and it compiles it further to native binaries. So from a developer perspective, think of it this way. You get the full, rich developer authoring experience of .NET code, so C# and VB that you're used to, but the performance wins of C++ code, of native code. You don't have to do the memory management. The compiler is smart enough to do that for you. And it's really powerful. We've seen 60% faster startup times. We've heard quotes from customers that it saved them up to 3 months of performance optimization work that they would traditionally have to do on a .NET application. So that's 3 months of more bug fixing, more feature adoption or feature implementation, and more delighted customers, hopefully. Now, there is one thing that there are a couple things with .NET Native that will adjust your typical development workflow, and that's what I want to tell you as developers or people interested in UWP. So with .NET Native, for the most part, your workflow is going to be unchanged. You're going to create a new .NET Universal Windows Platform application, and you're just going to edit and build and debug like you normally do. By default, when you compile and debug configuration, .NET Native is not invoked. So you still are running against the JIT, and you have runtime compilation of your application. Personally, I think it's easiest to just target local machine for this scenario. The value of the Universal Windows Platform is that the behavior of your app, unless you're using platform-specific APIs, should be the same on every device you target. So for me, it's just fastest to hit F5 on my local machine, make sure it works, and keep going. And then when I'm ready to test a big milestone, then I would target my other devices. And it's key that when you are ready to test those milestones, maybe an entire feature is complete, make sure you test in release mode and on all of the devices you intend to ship on. Now, .NET Native is a relatively new technology, and there were a couple issues when it first released, and it's gotten so much better over the past year. The team has been working really hard to fix all the bugs, but every now and then, you might see a compilation issue that you might not expect, or some runtime behavior that's a little wonky. So the last thing I would want for any of you to do is spend 6 months building your application, only testing in debug mode, get to release, you test release mode, and something fails. So it's much easier and more convenient if you test this once, twice a day as you develop. That way, you're scoping back a day's worth of code and not 6 months worth of code to figure out where the issue is. Now, this doesn't happen very often, and if it does, I encourage you to reach out to the team. If you just search .NET Native issues, you'll find a million things, and the team is extraordinarily responsive. But they'll make sure to help you get unblocked if you do encounter an issue. Finally, the last thing I want to mention is that when you're getting ready to submit your application to the store, it's essential that you publish the AppX upload package, not the other packages. Now, I mentioned that the store does the compilation for you with .NET Native. And the reason for this is just in case there was ever any sort of issue with the compiler that could impact security or functionality, we can fix it, recompile the apps that we already have uploaded, and customers are good to go. We don't have to require the developers to re-upload a new package. This hasn't happened yet. We don't ever expect it to happen yet, but it is just in case. By publishing the AppX upload, you're guaranteed to publish the right binaries, the managed binaries, not the native binaries, because it has to be compiled further. And you're also guaranteed to have all of the necessary store metadata to successfully publish. All right, hopefully that wasn't too much history. Let's talk about the app we're going to build. So not too long ago, a friend came to me. I'm from the Seattle area, and they wanted to open up a coffee shop. How typical. Like any new business developer, new business owner, they wanted to be smart and lower their chance of risk. I mean, any new business endeavor is going to be risky. And in order to lower their risk and optimize their chances of success, they want to be more data-driven. So they came to me asking, how can I automatically answer all of these questions in my store? How many people are currently in my store? Maybe I'm working solo. It's a new shop. Maybe I'm in the back, and I don't even see all my customers there. What if someone enters my store and I'm not around? Say I'm doing inventory or bookkeeping. I want to be there to greet my customer. What's the busiest time of the day or the busiest day of the week? Now, I know I'm going to be alone for a lot of the times, but when do I actually need to hire help to make sure that operations run smoothly? And finally, how can I quantify the success of any promotions that I run? Do I know that my buy one, get one free deal is bringing in more customers? Is it worth doing, or is it just a cost that is no value to me? So we worked together, and we came up with a design for the application. And this next slide might be a little overwhelming at first, but we're going to go through each component step by step together. And that's why we're going to spend a lot of time in Visual Studio. So the design we came up with leverages .NET technology and the Universal Windows Platform. What I'm going to do is I'm going to use an IoT device, a Raspberry Pi 2, hooked up to a couple of sensors, which you see here. And that'll help me determine when someone enters or exits my store by some clever logic and some infrared beam sensors. As soon as that happens, I'm going to send a post message to an Azure-hosted ASP.NET Web API, which is then going to write that information to another Azure-hosted service, a document database, a document DB service. And it's also going to send a push notification to a desktop/mobile application to say, hey, someone has entered your store. You should go greet them. Finally, there's another Windows 10 component, which is the mobile and desktop app. And that's just going to give me some information about my store and visualize some of that data so I can make meaningful decisions based on it. So the way we're going to do this is first we're going to build the Azure Web API. Now, this isn't an ASP.NET talk, so all I'm going to do is show you some of the powerful tools in Visual Studio that enables you to interact with Azure, so you never have to leave the IDE. I think it's really cool, and I think it is important in a .NET end-to-end developer's workflow. After that, we're going to build the IoT application and make sure that it is successfully writing to my database. And then finally, we're going to just take a look at the data client application. That's a big app to build, but I'm going to show you some really neat tools that are coming up in the next release of Visual Studio that help you build and optimize your XAML. So we actually have UI performance diagnostics now, which it's always a hard thing to get your UI perfect. So let's go ahead and get started. We're going to start with the ASP.NET app. Need to make sure I switch to the right one. So here I am in Visual Studio 2015 Update 3. This is the latest actually released version of Visual Studio. And I'm just going to go ahead and open a pre-existing solution. Now, for the most part, this solution is empty. We're going to start just from scratch. All I have is a portable class library that I'm sharing across the other apps. Now, I mentioned that .NET Standard tooling is still in development in Visual Studio. And with the next major release, you could expect more bug-free tooling, if you will. And I'm already doing a lot in this demo. So I'm still using portable class library. But it's really simple code, so worrying about the intersection of APIs is not really an issue for me. All I really have is some object models, and the one of importance here is really the triggered event object. And all that's going to have is a property of Boolean event type. Did someone enter or did someone exit my store? And at what time did that event occur? So date time. Then I'm going to override the toString method to make some demo stuff easier later, and you'll see that in a moment. But that's it in terms of shared code. And these are just visualizing them in meaningful ways in the graphs later, but it's a similar concept. So let's go ahead and add a brand new project to my solution, which is my web API. So I'm going to go to Web, ASP.NET application, and I'm just going to go ahead and call it Event API. Now, the first thing I want to point out is if you were to select Host in the Cloud here with Azure, and you had an Azure subscription active, you could actually build your Azure service right here in Visual Studio. So I don't ever have to go to the portal. Now, I already have a live service running that I've used before, so I'm not going to select this, but I will show you how easy it is to publish to existing services as well. So I'm going to select Web API, and I'm just going to hit OK. Now, this is going to create a pretty hefty project. It's not an ASP.NET Core project. It's just a .NET 4.6 project. And there's a reason for that, too. One of the SDKs is not quite available in .NET Core either. All this latest and greatest technology, some of the tools have to catch up. But I know it's on the roadmap for the end of this year. So the first thing I'm going to do is just add an existing class. Like I mentioned, this isn't an ASP.NET talk, but I will walk you through the code and show you it's just .NET code. It's nothing too complicated. So I'll go ahead and add existing item, refer to my desktop, snippets. Cool. So first thing I'm going to notice is some missing references. And the first one I'll resolve is just the reference to my portable class library. I'm sharing code across all the different projects. So add reference, projects, Shop Analytics PCL. Now what you'll notice is I actually get an error here, and this is by design. So by default, when you target .NET Framework with ASP.NET, it targets .NET 4.5.2. Now, my portable class library targets .NET 4.6 and UWP. So in the .NET Standard world, I could construct my shared code library in a pretty easy manner to work with this application without having to worry about API intersection again. But before I do that, before I actually share the code, I'm going to first have to update my target for my ASP.NET application to ASP.NET 4.6. So now let's add the reference. There we go. Cool. Now I'm missing a couple of NuGet packages as well. Oops, sorry. I'm using push notifications, and I'm writing to an Azure document database. And both of those have NuGet packages available for their .NET SDKs. So let's go ahead and add those references as well. Document DB. Let's see, I've done this before. Microsoft Azure.document database. And this will take a second because it's installing it from NuGet.org. So let's take a look at this class first. And this is the only controller that I'm actually building that's custom for my application. So for those of you familiar with web APIs, this is really just a simple post and get method that's interacting with some cloud services. So the first thing you'll note is some keys and some metadata about those cloud services. So the endpoint URI is going to be essentially the URI for my document database. And then I have the name, the collection name, and the document name. And to keep the demo simple, all I'm using is a single document. So I'm going to list all of my events in a single document, and that's so that it's easy to paste fake data. And then I create my document, or I declare my document client object. Then I have a get method, which is essentially just going to read all of the objects from that database and return them to whatever's calling it. And then my post method, which takes in a parameter of my object, my triggered event object, which is defined in my portable class library. And it's going to send that information to my to my document database and record it. So the only other thing I'm missing is my push notifications NuGet package. So let's go ahead and add that one as well. Push notification. There we go. Now finally, what I want to show you is how easy it is to actually publish this application to my Azure hosted service. Again, I'm not going to have to leave Visual Studio. I could just go ahead and do it. So pretty confident it'll work, but we'll debug it as well. So before I can debug the live service, I'm going to right-click on my event API, find publish somewhere, there we go, and select Microsoft Azure App Service. Now this is going to load my credentials from my Visual Studio account, and I'm going to select Shop Analytics Demo, Shop Analytics Service. Now there's a wizard that'll guide me through the process, but if I was ready to go and I was ready for production, all I would have to do is hit publish. Since I want to attach a debugger and make sure everything is working as I would expect, I'm actually going to change the configuration to debug. That's the only modification I'm going to make here, and I'm going to go ahead and hit publish. Now what you'll see here is you should see my browser launch with a new tab that is hosting my ASP.NET Web API. Now the UI you'll see is just the generic ASP.NET UI, but what it's doing behind the scenes is what's more interesting. So this will take just a second. There we go, Shop Analytics Service.azurewebsites.net. Should take just a moment to start up. There we go. So now let's make sure it works. I'm going to go ahead and attach a debugger to this and try both the get and the post method. First I'll try post, and then I'll try get, and I should see the event I post. So in order to attach the debugger to the live service, I can use the Azure SDK and the Cloud Explorer, again, built into Visual Studio, find my service, and just hit attach debugger. And now, when that method is called from anywhere, that breakpoint should be hit. So if I'm calling it through one of my client applications, or if I just use a web debugging tool to send HTTP requests, it doesn't really matter. That breakpoint should be hit. So I'm going to wait for the page to fully load, and then I'm going to use a simple web debugging tool that allows you to send HTTP requests however you'd like, called Postman, for those of you familiar with it. There we go. Let's make sure the symbols are loaded properly. It looks like everything is expected to work. So in Postman, all I'm doing is I'm sending a post web API call to this service with this event API information. And the content that I'm sending is actually going to be, I want to make sure I send it as JSON because that's what the API is expecting. And I'm just sending a single event for today, September 27th, at 21 o'clock, which I think is 9 p.m., and this is like global standard time. So you might see some time manipulations, but let's go ahead and hit send. And you can see Visual Studio is flashing. Cool. I can see the breakpoint is hit. Now it's going to take a second to load the local variable information as it's debugging a live service. There we go. So I can see event type is true. I sent a true event if I return to Postman. Event type is true. And time is exactly as I would expect. So let's go ahead and continue. And in order to make sure it's actually writing to the document, that's stage one that I know it's working. This device is already registered for the push notification service because it was running the client app before, so I get the push notification. That's a good sign. Now let's test the get method and move on. So I can do get. Go ahead and hit send. There we go. It hits as I would expect it. I can just go ahead and set another breakpoint at the very end and make sure that there's only a single event because I cleared out the database before this. There is one event, and now when I continue to execute, I can see in Postman, this is what was returned, which was the event I just sent. So I'm pretty confident this is working, but I'm actually going to leave the debugger attached for now because we're going to build the next app, which actually talks to this. So the attach to post first. Return to the slides for just a second, which I think is 5. So quick review, what we built already was pretty much this whole right side. So we have the Azure Web API post method, the Azure Web API get method, the post method writes to the database, sends a push notification, and the get method returns all of the events that we've already written to the database. Now we're going to go into the Universal Windows Platform land and spend the rest of our time there. So the next thing we're going to build is the IoT app. The data visualization app is not going to be very exciting if I have no events to actually visualize. So let's build the thing that will send events to the cloud. So again, returning to Visual Studio, I'm actually going to open up the next preview of the next release of Visual Studio, which is Visual Studio 15. And we'll spend the rest of our time there. So I'm going to go ahead and open the same exact solution. Open, which is saved on my desktop for convenience. And we'll add a brand new Universal Windows Platform project to this. Now, just out of curiosity, how many of you have played with a Raspberry Pi before or have done any sort of Arduino IoT development? That's a pretty big handful. Great. So what you'll recognize with any sort of IoT development is that a majority of the code is really just initializing what's connected to the board. So I'm going to declare some variables that are essentially pin maps. I'm plugging into pins that are represented by integer values that let me interact with input and output devices. That code is boring. I don't want to write that code, so I'm going to copy and paste that, and then we'll write the logic together. And I'll show you how easy it is to build IoT applications using .NET. It's really amazing. So right-click, add new project, Windows Universal, IoT client. I'm going to target the anniversary edition of Windows 10, which is the latest release version. It doesn't matter, all of the APIs I'm using are available in any version of Windows 10, but I like to use the latest and greatest stuff. And then what I'm going to do is just go ahead and insert a code snippet from my desktop, which is just preparing the board. It's not doing anything other than making sure everything is there. So I will replace this. And we'll walk through this, but it's boring to write. So in the constructor of the main page, this is just a XAML application. So it does have a main page, and it does have a UI. All I'm doing is creating my HTTP client, which is going to be used to send my post message to my web API. And I'm going to add that reference now. And then I'm calling this other method, init GPIO. Now, if any of you go through this getting started documentation or the hello world for IoT, you should recognize this same method. And this is pretty much reused for just saying, all right, I have these devices connect to this board in this form. So inside, again, I'm referencing some keys from my portable class library. So let me add that reference first. And then I'm declaring some constant integers that map to specific pins on the Raspberry Pi that are connected to my devices plugged into it. And I have 2 infrared beam sensors and 2 LED indicator lights. So when one of them is crossed, the light should turn on. And when it's not crossed, the light should turn off. I have to add a reference to the GPIO pins, which is just an object that represents what's on the pin. And then I have 2 Boolean values that I'm going to actually use for the logic. And we'll review the logic when I deploy this app. Finally, I have my HTTP client to send post messages. And the only missing thing is actually my GPIO status, which is a text block that I built on the UI to tell me, am I deploying this to the right device? So one thing you'll note is I'm creating a GPIO controller at the very beginning. And only Raspberry Pi 2 type devices, IoT devices, should ever actually return a value other than null. That said, the API does exist on other Windows Universal devices so that when this code executes, an exception will not be thrown. But what I can do then is, if it is null, that means I'm not on the right device. I'm deploying this to a desktop or a phone or something that will not support this. So I can actually give a message to the user saying, there's no GPIO controller on this device. You can't do anything. Just helpful for debugging. So let's go ahead and actually add in the XAML. And again, I'm just building XAML for my Raspberry Pi running Windows 10. How cool is that? So text block x:\name equals vertical alignment. I'm going to put it in the center and make it big enough to read. Font size equals 50. Cool. So now the last thing that's missing is these event handlers. Oh, sorry, I skipped a step. So the other thing that I'm doing is I'm actually opening these pins for these devices and saying what kind of devices are they. So I set their drive mode to either input or output. Again, this is just making sure the board's ready. An output device is anything you write to, such as a light. You can write a value to turn it off or a value to turn it on. An input device is anything that you read from, such as a button, a sensor, anything that you're actually reading the value from the board. So the only thing that I'm missing is in these input devices, when the value changes for those input devices, I want to react. That's how easy it is to build IoT applications. You're really just reacting to event handlers based off of what is physically happening in the world. So I'm going to go ahead and create those methods. I'm actually going to get rid of the new not implemented exception and place 2 breakpoints and test my code right now. Now, one downside to such a cheap computer is that the first time you hit F5, it sends over all of the remote debugging tools that are needed to interact with Visual Studio. So it takes a couple of minutes. So we're going to return to the slides as this deploys, but let's get it deploying first. So I'm going to set target device to remote machine. And I copied the IP address before, but just in case you're curious to what a Raspberry Pi with Windows 10 looks like, this is the default screen you would get when you boot up a Raspberry Pi 2 and plug it into a display running Windows 10. So I can see I've got my IP address listed here, and that's how I'm going to deploy my application to it in Visual Studio. So let's return to Visual Studio. I just copied it, so I can copy paste. And now I'm going to set it as the startup project. It's the last step. Where we go? There we go. Now, like I said, this is going to take a couple minutes. So let's go ahead and return to the slides for just a moment and explain what we're actually going to do to enable this scenario. So this is a top-down view of my device, if you will. Unfortunately, this doesn't zoom out quite as much. I'm going to show you the intrinsics of this when we make sure everything works. But this is a top-down view looking at the sensors that I have. And I have 2 infrared beam sensors right next to each other just to give me a direction. That's the only reason there's more than one. Is if one is crossed first and then the other one, I know which way an object is moving. So as soon as my customer, in this case my Ninja Cat riding a T-Rex, crosses the first sensor, I'm going to change one of the values of my Boolean objects that I'm tracking that are going to help me keep the information that I need. And then nothing else is going to happen. That's all I'm going to do. Now, as soon as the second one happens, I'm actually going to send an event. I'm going to write my post method to my cloud service and say, hey, an event happened at this time, stored in the database. In addition to that, I'm going to immediately reset the state of the device so that the next customer that walks through my door is ready to go. Now, for a small door with one person coming in and out, this should work OK. You could get way more advanced using proximity sensors for a big door. But for just a simple scenario, let's go with this. Whoops. I forgot to add a reference, so it did not deploy. So that'll take another minute. So that's a good point. Any questions so far? And if not, I'm going to torture you with a joke. Yes, question? So when you deploy, you can set the startup application of the device through Visual Studio. That's a good question. So what I did when I set the startup application was actually determining which project in Visual Studio would launch when I hit F5. So there are deployment errors. Sorry. Output. Did I type in the wrong IP address? Sorry. So let me finish the question first. So there is a way to set the startup application of the Raspberry Pi device by using what's called the Windows Device Portal, which is essentially a web interface that connects to the IP address that gives you a whole bunch of information on the device. It's how you could set the startup application. It's how you could change the name of the device and set some other properties as well. If you just search Windows Device Portal, you should find more information on it. Let me try this one more time. Oh. I'll show you my mistake so you don't make the same one. So I made a mistake. My mistake was I accidentally set this to Windows Authentication mode, which is the traditional way to do it for desktop-to-desktop remote authentication. For any Windows 10 device that is not a desktop, make sure you set this to Universal Authentication mode. The key difference here is for those of you who have done remote debugging, you'll recognize that you actually have to install the remote tools on the target desktop, whereas with universal authentication, Visual Studio does that for you. So it is actually copying the same tools over, which is why the first F5 takes a moment. Any other questions? You guys want to hear my terrible joke? All right, joke it is. So a physicist, a mechanical engineer, and a computer scientist are driving down a mountain road. And fortunately for them, there's guardrails, because unfortunately for them, their brakes fail. So they're just spiraling out of control going down this mountain. Can't really do much other than steer and hope for the best. So fortunately for them, they find a runaway truck ramp. So they're successfully able to pull off on the runaway truck ramp and stop to safety. Oh, it's working. So when they come to a stop, the physicist first says, I'm going to need to do some numerical analysis on some of the variables that could impact the brakes and why they failed. What was going on that caused them to fail? The mechanical engineer exclaims, I think there's a toolkit in the back of this car in the trunk. Maybe I can actually just fix the brakes and we can keep going. And finally, the computer scientist chimes in with, I don't know. I think we should just keep going and see if the issue reproduces. This should be done in just a second now. And in fact, as soon as it's done, I'm going to switch displays to the projector. And you'll see I'm going to deploy this multiple times. This is really just a first-time hit. It's a $40 computer. It's pretty impressive what it can do. The next F5 is going to be very quick. And let's see if it's actually registering. You should see a splash screen for my UWP app. Oh, deploy succeeded. Any second now, you should see the splash screen. Then the app will launch. And then the next time I do this, it'll take 10 seconds instead of 2.5 minutes. Any other questions as we wait? I didn't prepare any extra jokes. I made a mistake, so. Deploy succeeded. There's the splash screen. And let's make sure the app fully launches. GPIO pins initialized correctly. So if you remember, that's telling me that I am actually deployed to the right kind of device to support the program that I've written so far. So let's return to Visual Studio. I know this is the hard part, is going back and forth between a lot of devices. In my IoT client application, what I want to do is I want to set a breakpoint on those event handlers to track the variables that are happening. What's going on when I hit the breakpoint? How can I actually write my logic? What variables do I track? So in my main page.xaml.cs, I've already got the breakpoint set. So now we're going to go over to the actual IoT device, and we're going to test it. So let's go ahead and turn on the lamps. Sorry, wrong one. That's a lot to remember. There we go. So let's just quickly review what's actually plugged into this. It's not too much. You can see 2 LEDs. I'm probably going to hit a breakpoint accidentally. A couple of resistors, which are pull-up resistors, to make sure that the devices work properly. Again, this is information you would receive just by going through some of the getting started material. And then the Raspberry Pi itself, get that into view, which is hooked up to 6 total pins, 2 of which are just hot and ground, which is voltage and ground. So 2 of them are providing power to my breadboard, and the device is connected to it, and the rest are plugged into physical devices. That's really all there is to it. As you can see, on this side, I have 2 infrared LEDs hooked up. So if I do it like this, they're just like that. And then on the opposite side, directly in line with them, I have the sensors, so that when the beam is broken, it knows. So let's go ahead and try to hit a breakpoint. I'm going to stick my hand through this, just through the sensor, and return to Visual Studio. And I think I actually did hit the breakpoint accidentally, but that's all right. So now I hit a breakpoint, and I'm debugging my application. The value of that sensor changed successfully. Let's take a look at the local variables at this moment. This will take a second to load. It's pretty amazing what a Surface Pro 3 can do. Two instances of Visual Studio running at once. So the variable of interest is really going to be the arguments passed into that event changed method, or value change method. And the enumeration that I'm curious to track is the edge value. So again, if you go through any sort of IoT training, you'll recognize arguments.edge is how you track whether the value is increasing or decreasing. But for all intents and purposes for this, it's just 0 or 1, so it's really simple. All I can write, let me go ahead and stop this for now. And that was my entry sensor that was hit first. If args dot edge equals GPIO pin edge dot falling edge. What my debugging told me is this is when the beam is broken, because this is the value of that enumeration at the instant that I covered the sensor. So beam is broken. Whoops. And the opposite is true if it's equal to rising edge. So beam is unbroken. Did I hit caps lock? I did hit caps lock. Else. So from this, I can write the rest of my logic. Really, that's the only thing that was missing in this puzzle. The rest is just changing the values of Booleans. So when entry-sensitive value change is when the beam is first broken, I'm going to change the value of that Boolean to true. Equals true. Now, if exit was already equal to true, if the other value was already equal to true, then I know an event happened. Someone was leaving the store. Exit was fired first, then enter. If exit, customer has entered, and then this is going to be false, right? Because exit was crossed first and then enter. That is the definition of someone leaving as I have it. And I'm going to go ahead and create this method, and we'll implement it later. Now, the only other thing I want to do after this is reset the state of the device. And then I'm done. Like, that's it for that method. Now, the only other thing that I want to do is I want to turn the light on so that I can see physically something is happening with this device. So I just so happen to have two handy lights called entry and exit light, .write. And the way I'm going to do this is I'm going to write a value to that input device, or output device. So again, this is learned from like the hello world of IoT. It's just getting an LED to blink. So if I write GPIO pin value.low, it should turn the light on. And finally, else, all I'm going to do is turn the light off here. Oops. Cool. Now finally, let's just copy and paste this entire code segment into the other method and reverse some of the variables, right? It's the same exact logic, except when the other one is triggered versus this one. So instead of setting enter to true, I'm going to set exit to true. Instead of turning on the entry light, I'm going to turn on the exit light. And finally, I'm going to say if enter is true, customer has entered true. Right? Now someone has entered my store rather than exited. Finally, if the beam is unbroken, I'm going to turn the light off. That should be it. So now I'm going to place a breakpoint in my brand new method. I'm going to get rid of this. And I'm going to swing my hand back and forth a couple times and make sure it works. So let's go ahead. And here's proof that it should go much faster this time. And again, this is actually deploying new binaries because I changed the code. It's recompiling it. So it's really just the remote debugging tools. It takes forever. So we can take a look at the IoT device, make sure it deploys successfully. There you go, much quicker that time. No terrible jokes this time. Great. So let's take a look again at this, and I want to see the lights turn on. Let me turn this lamp down. You've seen what it looks like. Turn that off entirely. So if I cover the first one, I see the yellow light turn on, right? And I can actually bring this into view. So you can see the light closest to my hand is the one that turns on. Now if I turn this one on, hit the breakpoint. I did hit the breakpoint before I turned the light on. Oh, that's right, I hit the breakpoint in the first sensor. So yeah, my bad. You guys are on top of it more than I am today. Still getting adjusted to that Eastern time zone. So I hit the breakpoint, and I can go ahead and continue. But let me remove that breakpoint, because the only one I want to track right now is when an event occurs, so that I can do both simultaneously. Cool. I left the breakpoint. So I'm going to go ahead and continue execution of my code. And now a customer has entered, and now you can see the red light turn on. And the red light is going to turn on and stay on because, again, I hit a breakpoint, and this is the method that I'm going to essentially write to my ASP.NET application. So if I return to Visual Studio, whoops, wrong one, I can again track my local variables and see what kind of event was that when I go from this side to this side. And that's true. So this is my storefront, right? If I go this way, I'm going into my store. Now let's continue execution and try the other way and make sure my logic is working as I would expect, just for sanity's sake. I'm not going to revert here, but you can probably see the lights. Red light first, yellow light stays on as I would expect. If I return here and take a look at my local variables, now it's false. Great. So my logic seems to be working. It's simple. It's probably fragile, but this is just a demo. So let's go ahead and actually write my method to deploy it to my Azure service. So the only thing I need to do now is create my HTTP content and post it asynchronously to my web service so that this code can continue to execute, right? I don't want the code to wait for the response and have people go through and I only send 1 out of 10. So the way I'm going to do that is going to first create the event object. And the loss of IntelliSense is a result of preview bits. Don't worry, this is not an actual issue that you should experience. I'm using like a daily build of Visual Studio. So So I get to write this code by memory. Event type equals true. Event time equals datetime.now. I think that's right. And then I get to create my HTTP content using that knowledge, using that event, because that's what, oh, made a mistake. This is always going to be an enter event. Event type equals v. Yep, that's the Boolean I'm passing into the method. And let's go ahead and create the HTTP content to send to my web API. Content equals new string content. And here's my sanity. I still get the method information. So I'm actually going to use the third overloaded method, specifically because I want to tell my web API that this is JSON. This is JavaScript object notation that I'm sending to my API, because that's what it expects. And the only way for me to do that is to say string media type equals application/JSON. So the content is really just going to be tEvent.toString. The encoding is just going to be UTF-8. Coding.UTF-8. And media type is going to be application/JSON. And finally, the content is created. The last thing that's remaining is actually posting that content. So let's go ahead and client.postAsync content. Now, I don't need to await this. I don't really care for the response. I really just want my web API to get that information. If I wanted to do debugging, I could await the response and figure out what's going on, but I don't worry about that. What did I do wrong? I shouldn't if I'm not awaiting the return. Oh, I know. This method doesn't take only one parameter. The 4 awaitable types take the string request URI, which is my bad, and then the content. It's hard to do this without IntelliSense. So the request URI is just the part of the web URI that's appended to say this is the API I'm calling. And in my case, it's API event. If you recall from Postman, this was just the very end of the URL, and it's specified when I add my new controller to my ASP.NET application. All right. Ooh. So let's try this one more time. I'm going to place a breakpoint here, and we're going to see it work in action. I'm going to do 2 breakpoints, actually, one at the very beginning of this method and one at the end. And we'll see what we get. See if I do memorize all of that code. Then, oh, no. So this happens every now and then. If you wait too long without doing anything with your Azure Connected debugger, it times out. So because I messed up my IoT thing, it timed out. So in the other Visual Studio, I'm going to reattach my debugger. And the reason for this demonstration is to show how easy it is to build connected experiences and debug them simultaneously. I could have my server code debugging in the cloud, live running service, with my client application talking to that cloud service, debugging the variables there, and see everything in action. Now, it seems kind of silly in a demo like this, but when you're trying to figure out where something is lost or where something is going wrong, it's extremely valuable to be able to have this power. Cloud Explorer. So this happens when it times out every now and then. Let me restart Visual Studio for this version real quick. I think you get like 10 minutes or something, and I just went over it. So close. If this doesn't work, we'll just move on to the last part. Let's see if it works. And again, any questions while we wait? Should take a couple seconds. Yes? So the question is, have you deployed some version of Windows 10 to the Raspberry Pi? And the answer is yes. So before this session began, and a long time ago, I created a Windows 10 micro SD card using Windows 10 IoT Core. And you can essentially just download the image from the web. It's free. Copy it to a micro SD card, plug it in, power it up, and you're good to go. Does server core for Raspberry? Sure. Does Windows 10 IoT Core have a non-GUI version? Yes. So you can actually author what's called headless applications for your Windows IoT device, and there will not be any UI for that. It's just however you want to define how to interface with that device. Good question. Cool. So I don't care about Git for now. We're actually going to be posting. So I have my post breakpoint set. And what I'm going to do is actually put these 2 instances of Visual Studio side by side. So first, let's go ahead and do an event. Now, realistically, someone's going to enter my store before anyone can exit, so let's do just that. First, second, it's going to stay on, breakpoints hit. This should be a Boolean value of true. I'll go ahead and keep that up. Great, true. I'll go ahead and continue to execute, and I'll make sure that I sent the right type of information. So one thing you'll notice that is a little bit interesting is that this method is going to continue to execute and actually hit the breakpoint after post async before the cloud breakpoint is ever hit. Now that happens because, again, this is happening asynchronously, right? The information is sent to the web. Who knows when it's actually going to hit it, right? So I can see the event type is true. The time that I'm kind of curious to make sure it is right now. My computer's still set to Seattle time. It's actually 4:50. But let's go ahead and continue. So as I continue execution, I should see something here. Oh, do I? Here? Am I in the gate breakpoint? I shouldn't be. Oh, there we go. That was weird. Thank you. Yep, so there we go. I hit the same exact breakpoint. I can inspect the variable, the event that I just sent, and make sure it's exactly as I would expect from the other side. Now again, this seems trivial. This seems like an easy scenario, and that's because it is. This is a demo. But when you're building client applications that integrate with Azure services, this is really powerful. And again, I can take a look at my new event. Can go ahead and check 8:50, 14 p.m. So again, I mentioned that the other time was, this is global standard time that it's writing. So it automatically converts that information, which is really nice. That's what's nice about using datetime in .NET. I can hit F5, and now I should see a push notification. Great. End-to-end is working, just as I would expect. So that's not the end, but we're getting there. We just have one more component, and then I'm going to open it up to general Q&A for the last 10, 15 minutes or so. I always forget this. So IoT is done, Azure's done. All that's left is, I want to see something interesting. So I'm going to create the mobile and desktop app. I'm just going to create a single app that is going to have some sort of adaptive UI to scale across. I'm going to launch the app, refresh the data in the client. I actually do the data processing in the client. I don't offload that to the cloud. That's bad on me. I should fix that. But again, for a simple demo, it works. And then I'm going to send the GET message and update the UI. So let's go ahead and see that in action. Before we do that, though, the last thing I want to do is first close this instance of Visual Studio. Sure, my Surface Pro 3 doesn't like me as it is. And I'm going to stop debugging this, but I'm going to hit Control F5 to deploy the application to the IoT device without debugging. Now, a funny story, these things are surprisingly reliable. This has been one of the most reliable parts of my demo since I've used it, and it's incredible. Like I once deployed the application and went on vacation for like 2 weeks. I came back and swung my hand across and got a push notification. Everything was working as I would expect. So it is really cool. You can just leave the app running forever. To speak to the question you had, or I had earlier, you can also set a startup application. So as soon as I plug it in, I could have the app running and ready to go. So if I'm using this for a very singular purpose, and some reason I lose power or something happens, as soon as it restarts, the app is going to be running, and it's probably going to work. It's pretty amazing. So that's deployed successfully. I can test it. Let's just go ahead and test it once. First time takes a second to send the info. It's warming up. I should see some sort of push notification. Great. Now let's add the final application to this and actually add some fake data to my cloud database because otherwise the UI is going to be really boring. So add existing project. Desktop, snippets. So there is a tool to actually interface with the document database in the Azure portal. There's also a tool in Visual Studio. But what I'm going to be doing is uploading a significant amount of data, some like 7,000 lines, and doing it in Visual Studio every now and then isn't quite as reliable as just doing it in the cloud. But that said, there are redundancies. So if you are having any issues with the tools, there's likely a web tool too. You might have to break out of your traditional workflow, but whatever. So this is the document that we've been writing to, and these are the events we wrote to in this session. The first one is pretty obvious. This was written by Postman, because I don't have exactly what time occurred, and these two were from my hand swinging across. And just real quick, how cool it is. I'll go ahead and swing my hand. Someone has entered the store. I'll refresh this, and I should see a fourth event. So that's how fast it is. So let's go ahead and just remove these for now and upload my fake data. Fake data. And go ahead and save that. And what did I do wrong? I believe I did this wrong. this is neat too. The tool itself is like a JSON editor that will tell you if your JSON isn't formatted properly so that you don't break something. So it's pretty neat. Cool. So finally, the moment we've all been waiting for, all of this coming together in the visualization app. I'm going to go ahead and set it as my starter project, and we'll just take a look at what it looks like. So I'm no longer deploying to an ARM device. So take a sec. Local machine. It's going to build it and restore the NuGet packages, and then it should work. Now, the first time this launches, it'll take a second to get all the data. I'm using the cheapest ASP.NET web host you could use for Azure, but it's a little slow. So this is my Contoso coffee shop. I can see my hours of operations. When the insights are loading, I get this little progress ring, and there we go. So currently, there's nobody in my store. I can see that Sunday is the busiest day of the week, pretty significantly. So that's probably when I would want to hire help. Not only that, but yesterday, 5 p.m. was the busiest time of the day. So if I'm thinking that I need to hire additional staff, maybe it's the evening shift, I can probably manage 10 to 4 by myself. Don't need any help. And finally, I can see the weekend of September 11th, I ran a promotion and it was successful. I did buy one, get one free, and more people came in. Not only that, but I can see this is only, Tuesday? And 66 people have already come in. When 181 came in my best week, this could be on pace to be a similar week. Now let's go ahead and just see what happens when I swing my hand through. Someone has entered my store. I can now see the push notification. Someone has entered my store, and it's that quick. Now, what I want to demonstrate now are some really powerful tools to help you build performant and beautiful XAML UI. And I'm not the best designer in the world, but this is what I got. So I also have a menu, and I could actually, if I wanted to take this a step further, I could do everything in .NET to make this my point of sale system, integrate with some SDK that could take payment, and then integrate or correlate the data for pure revenue versus how many people come in my store, and I could do a lot more analytics. That's taking it way beyond, but it's pretty powerful what you can do with Windows 10, UWP, and .NET. So the first tool I want to demonstrate is actually a tool that's available in Visual Studio 2015 today, just not that many people know about it. And it's available both for UWP and for WPF development, and it's called XAML UI debugging. And essentially, for those of you who are familiar with web development, you have your visual DOM. You can see exactly what controls are on your display, and you can interact with their properties at runtime. So this Contoso coffee shop is very small and doesn't actually show off my brand. I want to make that a little bit bigger. So by default, this is enabled on any XAML application, which lets you interact with the controls on the UI. So if I click this, it doesn't look like much happened. But if I go to Visual Studio and I look in what's called the live visual tree, it navigated in the live visual tree. Oops. Like I said, pre-release bits happens every now and then. I might have to restart this in a sec. I don't need that right now. Let me go ahead and try to do that one more time. There we go. Sorry about that. So what that does is it actually navigates to that control in my running document outline is one way to think about this. But these are all the controls that are constructed on my page, both programmatically generated and user generated. So this little tick here means that I created that control. Not only that, but if I click it, it'll take me directly to that control defined in my XAML file. So just like that, I can see this visual object, I can see the code for it and the properties that define it. So the next thing that I can do is using that information, I can then open what's called the Live Property Explorer and inspect the properties of that control, again, the runtime properties of that control, to see, all right, what's good, what's bad. What's even more powerful is I can overwrite some of those properties and even create new local properties. So like I said, I think the font size is too small. Let's go ahead and change it. I think the default XAML font size is like 15. Let's try 24 and see if that looks better. So if I return to my app, I have to hit enter first. There we go. That looks a lot better, I think. So this is now running with the new property. I can inspect and look, all right, that's much better. Not only that, so that's available in Visual Studio 2015 today, but what's not available is being able to persist that information to my XAML file. So as soon as I stop debugging and restart, it's going to return to the same way it was before. But with Visual Studio 15, the next release of Visual Studio, there's no declared name, that's what we're calling it for now, I can actually go ahead and just edit the XAML file as my app is running. So I'll go ahead and change it to 24 because I think that looks pretty good. I'll hit save, and you're not going to see any change here, but if I stop and run again, now you should actually see that change persist. So what this enables you to do is to essentially build the layout of your application using the XAML designer, the XAML design surface, and the code editor, and then just run your app and start playing with the properties until it looks like the designer mockups, or until it looks like your own mockups. And this is the actual behavior of your app. So as you edit it, what you see is exactly what you're going to get on any one of these devices. So I mentioned that we were going to optimize this for both mobile and desktop. And the way I did that was just using adaptive controls and adaptive states. So as you can see, the grid view control automatically just adapts. I can scroll now, and I host it in a scroll viewer. And that's essentially what it would look like on a mobile device, maybe a little bit skinnier. I'm not going to run the mobile emulator because I've punished this computer enough with 2 instances of Visual Studio. It only has so much memory. But again, the insights, this is not a built-in Windows standard control. This is using a NuGet package called the XAML UI Toolkit for data visualizations. But it's really easy to build this adaptive UI. I have maybe 20 lines of code, and you can actually use Blend to do it yourself. But I'm just going to show you the code, because I think it's pretty straightforward. So all I'm doing is I have a visual state. Let me remove some of this stuff so you can see it. That is called wide view. By default, you're going to author your code for the narrow view, and that's how this triggers work. So I would build my UI like this first, and then adapt it so that when it gets wider, it works as I would expect. So what I do and what Microsoft typically recommends is you build your adaptive trigger for when the minimum window width is equal to 720 effective pixels, not actual pixels, so DPI scaling should work. But as soon as it's 720 effective pixels, I just have setters on essentially where I'm placing these items in my grid. So effectively what I have is a 4x4 grid, but I'm only ever using 2 rows and 2 columns, or 4 rows and 1 column. So there's only 4 elements ever in the grid, but that's how it works, and it just moves it. So from here to here is all I needed to do to adapt my UI for mobile. 20 lines of XAML. It's not so bad, and it's really just setter properties. Now, there's only one other thing that I want to demonstrate, and I think this is one of the most powerful tools that we're coming up with for XAML development in Visual Studio 15, so I saved it for last. And again, this is preview bits, so everything should work. I've tested it multiple times, but you never know. So what this tool is called XAML UI Analysis. Now, because this is such a new tool, we do not turn it on by default. We let you opt into it. But in your runtime diagnostics tools, whenever you're using any sort of XAML application, if you go to Select Tools, you'll see this UI Analysis checkbox. And what this does is it performs runtime analytics on your XAML application using a runtime service to tell you where we think you could improve your XAML. And those things could range from, all right, you're missing some accessibility properties, so your application might not be accessible, or you're not using compiled bindings. Maybe you should consider compiled bindings. Oops, sorry. Yes. So I have this filter to one that really caught my attention when I actually built the app. This was news to me when I built the app. But to try to make it so that you don't see these empty controls while I'm loading data in the backend, I hid my XAML controls while the data loaded in the backend, and then I made my controls visible using a type converter for XAML. Now, what UI Analysis told me was this was collapse at load time. Collapsing an element or setting its opacity to 0 will not prevent the element from being created. Effectively, I was using memory, I was using CPU to construct this control that was literally doing nothing. It was just hidden from the view, it would do nothing. Not only that, but I was able to click on more information on this issue, and it takes me exactly to the documentation about what is this issue and how do you fix it. So the way to fix this is to use what's called defer load strategy. And what that means is it's not going to load the control at all until you invoke it by some form in the code behind. And I'm already doing that. I'm already changing a Boolean value to show the object in the code behind. Why don't I do it the right way? So let's go ahead and actually fix that. And better yet, if I actually double click on that, just like with the live visual tree, it takes me to the offending code. Here's where I made a mistake. So think about it this way. As I'm building my application and I encounter these issues, I can fix them on the spot. I'm not waiting until the very end of my application development to think about performance and to think about accessibility and to think about all these other things that are just going to be really expensive to do at the end. So let's go ahead and fix it. So again, I can use XAML edit and continue for the first part by just deleting that. My app is still running. I'll add x defer load strategy equals lazy. And that's not quite the end. So I got rid of the bad visibility stuff that I was doing. But this is never going to load because I'm not invoking it in the code behind. So what I have to do in the code behind now is, this is my IoT main page. Let me go to my other main page. When the data loads, I just need to write this.findName, which is going to invoke the control, and then it'll load the control in the UI, and then I can do whatever I want with it. So where I load the data, find name, oops, and then it just takes in a string of the name for the control. Now, it's important that I write this before I set the item source of this control, or I'll actually get an exception because there's no object. The object is never created, and I actually made that mistake earlier. So again, you want to invoke it right before you need to use it elsewhere. So let's go ahead and deploy that one more time and make sure that that warning has gone away for UI analysis. So I'm just going to return to my diagnostics tools. Make sure my app has loaded fully first. Oops. Make this bigger. Everything is loaded. UI analysis, I no longer see a visibility collapse warning. That issue's fixed. I can check that one off the box and continue working. I think this tool is really powerful, and it's going to create more and more performant apps and more accessible apps. So that's it for the demos. Let's return to the slides for some closing thoughts, and then I'll open it up to some last-minute questions. So we built the entire thing. Looked kind of daunting at first, but it wasn't so bad, was it? So this is one example of taking Universal Windows Platform and applying it in scenarios that take advantage of device family-specific capabilities. Like I said, this contains a GPIO controller that can interface with these devices, while this doesn't. I want to tell you a story about an application that utilizes UWP slightly differently. And what they do is they utilize the same exact app to run on every single Windows device family. So Todoist is essentially a task management platform that I use regularly that built a UWP app that was featured as one of our applications when it was published. But what I thought was really neat is their app is actually available on desktop, mobile, and even Surface Hub. And they do have a business offering. They have an enterprise offering for Todoist. So it makes sense to run this on Surface Hub. So the same exact app will have a adaptive UI tailored for each device, and it can call into all of the different Windows services, such as live tiles or interactive toast notifications, you name it. So there's different strategies you can take with UWP. You can utilize device family specific stuff, or you can build the same app and run it everywhere. It really is powerful. So some key takeaways: build one app for all Windows 10 devices, or use device family specific capabilities. You can leverage Visual Studio and Azure to complete end-to-end experiences with, rarely ever having to leave the IDE. And you can write .NET standard code that can be shared across all of these platforms, and whatever future platforms adopt .NET as well. Here are some resources that I think might be helpful for you, including some of the source code. It's an earlier version of this, but I'll be updating it shortly. .NET Standard, there's a lot of great information. A blog post was written by one of my colleagues. And finally, if you're just interested in some of the APIs available in different .NET frameworks or different .NET platforms, you can go to APIs.of.NET. I think it's awesome. Some related sessions that might be interesting to you, if you thought this one was good, are listed here. I'll be talking again at the Discuss Cross-Platform Mobile Development at Microsoft panel, which is Thursday, if you want to come hear my voice again. And finally, whoops, there we go. This slide that they put in. I'm not as familiar with this one. Sure, yes. So I'll just leave it on this one for now. The last thing I want to say before I open it up to questions for the last 8 minutes is, whatever you liked about this session, let me know in the comments section of your evaluations. Whatever you think could be improved, please let me know that as well. I'm always trying to make these better and better for you. You're the reason I do this. So thank you so much for listening, and I hope you enjoyed. Any questions? Yes. If you're leaving, please be a little quiet so we can hear questions.
One was the NuGet package for the adaptive UI. What was that one called?
The NuGet package for the adaptive UI. So I use a NuGet package for the controls, the charting controls. It's called the XAML UI Toolkit, and more specifically, they have one just for data visualization. So XAML UI Toolkit for data visualization.
And then the next question is, do you ever foresee Windows 7 supporting universal?
The next question is, do you ever foresee Windows 7 supporting Universal Windows Platform? I don't see Windows 7 supporting Universal Windows Platform, but there is an ability for you to take existing Windows 7 applications to UWP with what's called the desktop converter. So we have the other way, but not that way. Will it work on a Raspberry Pi 3? Yes, it will also work on a Raspberry Pi 3. I just haven't gotten one yet, but soon enough. Yes? Is the sample code available somewhere? Source code, aka.ms/brk2101. Yep. Again, it's not the most current version, so I have some updating to do, some code cleanup to do, but the gist is there. Yes?
My question is about the browsers. We're hearing that all these applications will work across multiple platforms, which is very nice.
So the question is, will these apps actually work well with older browsers such as IE9, IE10? So this is actually a native Windows application platform, so it doesn't rely on any browser technology. All it requires is Windows 10. So if your customer has Windows 10, these apps will work. If they don't have Windows 10, you'll have to target a different platform such as WPF or WinForms or something like that.
Show next slide.
Yes, show next slide. No problem.
Actually, I think one after that.
This one?
Yeah. Perfect.
Yes.
Get the Windows 10 on the SD card, Raspberry Pi. Is that a fairly straightforward thing out there on the web?
To get Windows 10 on the micro SD card for the Raspberry Pi, is it a straightforward thing that you can just find on the web? Yeah. If you just search for Windows 10 IoT Core in any browser, the first result should have a Get Started link. And Get Started will guide you through the process to download an application that downloads the image that automatically formats your SD card. It's very simple. Yes? This one, yeah. Sorry. Those aren't my slides.
Windows 10 IoT support the rest of Azure SDK?
Sorry, what was that?
Does Windows 10 IoT support the rest of Azure SDK?
Does Windows IoT support the rest of Azure SDK? So any Azure SDK that is available in .NET Core-ish should work because it's just a Windows 10 application. As Windows evolves and supports more and more .NET Core technology, and Azure SDKs evolve to support more and more .NET Core technologies, which is kind of where everything is converging, more and more Azure tools will work. But a lot of them already do. Yes?
You said that it only works on Windows 10, but what's the minimum server that
What is the minimum server version that UWP will work on? I believe it is 2016.
so it doesn't work?
It will not work on Server 2012 because Server 2012 is Windows 8.1 based. Yep. Yes?
So if you had a server 2016, you just have an RDP session, the same thing, like your desktop's ready for,
If you had a Server 2016, you could set an RDP session to build these apps?
or no, to actually have your clients run them, like through the environment, if they don't have.
Sure. So to actually have your clients run on them, yeah, you could do that.
Yeah.
Any further questions? All right. Thanks for being a great audience, everyone.